In this video, we are going to discuss the second part of vector, where I will be speaking about a component form of a vector, component form. Before I go into component form, I should remind you about one thing. What do you mean by position vector? We usually mention position vector for a point. Yes, for a point. A point in the space. It's not on the plane, just on the plane. It has got three coordinates, x, y, z. It's fix a point in the space. To understand what is position vector, I should say about O, origin. Where is that origin? I'll take somewhere in this space a point which I am going to call as the origin, through which the x, y, z axis will be passing. Okay, now if the O is fixed, let me draw it here, O. I have a point here, A. O is the origin, A is any point. Now I will say what is position vector. The vector that is drawn from O to A, OA. This vector is called the position vector of A. The position vector of A is nothing but the vector that starts from the origin. Then what is the position vector of B? OB. Position vector of P? OP. OP vector. So any position vector of Q? OQ vector. So there is a definite length and a direction from origin to that point. Now with the help of this position vector, I am going to speak about how we consider a complete vector in this space. So for that, please look here. I have a vector here, AB. It's a very important learning, very important learning. AB is a vector. I'm going to recognize this vector with the help of position vectors. The origin, suppose O is the origin. I simply want to draw the position vector of the starting and ending point, initial and terminal point. That is nothing but OA and OB. Why don't you use triangle law here? It looks like a triangle only, no? Let me write. It starts from OA plus AB. OA plus AB is equal to what? OA plus AB is equal to OB. From here, what is AB? AB is OB minus OA. If I put the name P and Q, PQ vector is OQ minus OP, I will write. The second letter, you will take its position vector first. When I say once again, if I say PQ vector, I can, in the similar fashion, I can write OQ vector minus OP vector. This is a very important learning. Second letter first, its position vector first. Then the first letter's position vector. You know, this position is very important. Okay. Now, so with the help of 2 points or the line segment constituting, the vector constituting, if I put the arrow like this, what will happen? Then this has to be in another way. What? You have to do the triangle law like this. OB plus BA is equal to OA. From here, BA vector is OA minus OB. The rule did not change. What I said in the beginning, same rule. The second letter's position vector, OA first, minus OB vector. So you can put arrow in whatever way you like. Depending upon that, we will write. Anyway, the terminal points position vector minus initial points position vector. That is what basically you should understand. Even if the rest of the thing you forget also, you can manage. Okay. Now we are coming back to component form. What is component form? Okay, let us look at that. That's what I wanted to say here. In fact, I forgot to mention about position vector in the last video. Okay, anyway, that doesn't matter. Now, if I say what do you mean by component form? Oh, to speak about component form, I need x, y, z axis. It's a little difficult to draw the third axis. It has to be drawn like this. So I'll just draw to speak about this space. I'll draw two axes. Let it be x and y axis. Z axis over here. Now I want to choose a point P. This point may be 3, 4, 5. This, what is the meaning of 3, 4, 5? 3 units away in x-axis from the origin and 4 units away from the y-axis, the origin, and 5 units from z-axis. That's what 3, 4, 5 means. That is the position of this one. Now, I want to bring this point in terms of vector. What mathematicians have done, you know, what they did is they took the vector along x-axis. The vector along x-axis they took. How did they take it? What they did is they took a unit vector, unit length vector in x-axis, which they named as I, not just I cap. So I cap is a unit length vector in x-axis. Then what is in y-axis? In the similar fashion, they took it as a unit length, that is j cap. And z-axis they put k cap. That is also a unit vector. So I, j, k are unit vectors along x, y, z axis respectively. Now what is the use of this? Now this is my yardstick to measure. So 3 units means I will say 3i. So this is going to be mentioned as 3i, 3i units. 3i came or away. This means we will say 4j away. This will be 5k away. So we will sum it and write. Okay, how can we define this in another way? In another way, with the help of position vector also. See, from the origin, if you draw, what is the position? Origin's point 0, 0, 0. This is 0i plus 0j plus 0k. As I said, what is OP vector means? OP vector in another words is what? OP vector is from this point you have to subtract this coordinate. We said no, AB vector is OB vector minus OA vector. Here it is nothing but OP vector minus OO vector. So that is, if you subtract also 3 minus 0 or 4 minus, this is the final point. 5 minus 0, that's nothing but this same vector will come. This is one idea. So from this idea, when you get a vector like this, 3i plus 4j plus 5k or 3i minus 4j, so it will go to the respective axis, whether positive direction or negative direction. It depends upon that. With the help of this, I will be able to say about 2 points in this space and the vector involved that. You see this, I am going to write it like this. To one point is 2, 3, 5. Another point is 3, 4, 7, something like this. 2 points. How do I call this vector with the help of the components? What are components? I, j, k. With the help of components, how do I mention? To understand that, you need to remember once again position vector. Let me name this as AB. What is this? OA, position vector. OB, you know what? AB vector is OB vector minus OA vector. What is OB vector? Just now I said OB vector is 3i plus 4j plus 7k minus OA vector is, these are the components. So 2i plus 3j plus 5k. So what will be ultimately 3 minus 2? You can subtract it like this, components. 3 minus 2, 1i plus 4 minus 3, 1j, 7 minus 5 plus 2k. So this vector will be I plus j plus 2k. So when you see a vector, it may be a vector completely, or it may be the position vector of a point. When you see I plus j plus k, or 2i plus 3j plus minus 5k, anything like that. That idea you should have. This is the component form of the vector. Then what was that we discussed in the first video? That was capital A, B vector. That's only a representation. But mathematically it will become more meaningful when you speak about the component form of the vector rather than telling AB vector. We have limitation to work with this. But when you write AB vector as I plus j plus 2k, we can develop our idea. So this component form is important. Now, another important thing I want to add is, what do you mean by direction angles, direction cosines, direction ratios? I'll tell it in the simplest way possible. We are not going into the detail of the derivation of the property and all. So I should say, we will say usually this one, what is dAs, dCs, dRs, apostrophe S. Children, you take the XYZ axis, the Z axis also. You consider a point here, maybe P. Now I consider the vector OP. OP is a vector that starts from origin and ends in the point P. This OP makes some angle with x-axis. Not only x-axis, with y-axis also, with the z-axis also. That are generally notated, mentioned in mathematics as alpha, beta, gamma. The angle it makes with x-axis is alpha, with y-axis is beta. It's not I made, that is the common notion of it. And with z-axis is gamma. These are simply mean direction angles. There is nothing big about it. With x, y, z axis, what angle the particular vector which starts from the origin makes, they are called direction angles. These mathematicians have associated this alpha, beta, gamma with the cos function. That will become cos alpha, cos beta, cos gamma. Y means it will give a particular property. Actually, that is a 3D-dimensional figure which is discussed in our textbook. We can draw that and we apply that trigonometry over there. We will get a relation also. Okay, before that, what are cos alpha, cos beta, cos gamma are simply called the direction cosines. As I said, through a derivation, we can prove that cos square alpha plus cos square beta plus cos square gamma is always 1. If you want, you can convert this relation into sine also. How? 1 minus sine square, 1 minus sine square alpha, 1 minus cos square alpha, 1 minus what? Sine square beta. So that will become 3 minus sine square alpha plus minus sine square beta minus sine square gamma. You take to the other side, you will get a relation like this also. And take 1 to this side, you can write it sine square alpha plus sine square beta plus sine square gamma is equal to 2. This also you can prove by replacing this one. But that is not very, it's a matter of concern, but this is very important to understand that this is a relation. Now, the next thing that you should understand is, this cos alpha is what? It's a number. Cos 30 degrees, root 3 by 2. Cos 60 is 1 by 2. So it's a number. So when you assign an angle into that, it will become a number. These numbers, proportional values, if you take the proportional values. What do you mean by proportional values? For example, if I have numbers 1, 2, 3, the proportional value, you multiply this by a 5, you will get 5, 10, 15. These are proportional values. Or some other, you multiply this by a minus 3, minus 3, minus 6, minus 9. These are called the proportional values of cos alpha, cos beta, cos gamma. They are just numbers. They are called direction ratios. This much basically you understand. Later we are going to think in component form with the x, y, z, with I, j, k, what comes. We call it a scalar quantity which are going to be called as the drs. We will come to that. So that is, for example, if I write 3i plus 4j plus 5k, these 3, 4, 5 are going to be called as the drs of the vector. We can associate with that. And we can convert this drs to dc also. What you should do is, if it is dc, when you square and add, it should become 1. So how to convert this drs into dc? What you should do is, you have to divide, because if you add square and add, you see 3 square plus 4 square plus 5 square. Do you believe it will become 1? No, not at all. It won't become 1. But if you divide by each of these term, if you divide by 3 square, what is that? 9, 4 square, 16 plus 25. What it will become? It will become what? 25 plus 25, that is 50. So you divide by root 50. Divide by root 50. Divide by root 50. Then what you get is, this will be DCs now. This will be direction, because 3 by root 50 the whole square plus 4 by root 50 the whole square plus 5 by root 50 the whole square will become 1, just because of that. So I will conclude once again. We understood in this video what is a position vector. It is nothing but from origin to that point, if you draw, that vector is called a position vector. It also has got a length, it has got a direction. Then we understood what is component form. Component form means the vector of a point or a line segment, if we can represent with the help of I, j, k. I mentioned it. With the help of ijk. What are ijk? Ijk, I is nothing but x-axis only, a part of x-axis, which starts from origin, which 1 unit length. A part of y-axis, j cap. Part for k will become for z-axis. With the help of that, if we express a vector, that is called component form. We will go to component form in detail, and we should understand what are direction angles. A vector that makes with x, y, z axis, what angle? You can think about what I cap will make with x, y, z axis. You know that? It's possible. I cap, that is lying in x-axis. X-axis will with the x-axis, what angle it will make? 0 angle. X-axis with the y-axis, what it will make? 90 degree. X-axis with the z-axis, what? 90 degree. Therefore, the other two angles are 90 degree. So with x-axis it is 0 degree. So our direction cosines will be cos 0, cos 90, cos 90. Cos 0 is 1. Cos 90 is 0. This also will become 0. Okay, we'll think about it. So we'll say the direction cosines of, or direction ratios of, both way I can say. All direction cosines can be called as direction ratio also. It is a more generalized form. The other way it is not possible. Okay, anyway, ijk. For I we can say 1, 0, 0 z axis. For j cap we can say direction cosines are 0, 1, 0 z axis, 0, 0, 1. We'll come to that. So that kind of an idea you should have. What is the? It is the angle made with the x, y, z axis. Its cosine value is direction cosines, and proportional values are direction ratio. You understand that much? Then we will discuss about dot product, cross product and all. When we work out some problems or we will discuss such questions, then it will become easy. Okay, thank you.